In this video, I just wanted to kind of revisit a couple of things with the hypothesis test, remembering that on the AP exam, you are certainly going to be asked to do one of these in the free response, and you're going to be asked various things about them on the multiple choice as well. So I wanted to just talk about a couple of things. First, what you do in that kind of state step for these. Okay, so stating, let's just write, okay, for the t-test, remember we always put our null and alternative in terms of the parameter. So t-test is testing a sample or a mean, so it'd be mu equals blank, and the alternative, of course, would be that it's not equal, that it's greater than, that it's less than, that same number. But it is mu equals. Then we will say, we have to define our parameter. Mu is the population mean, and then, of course, put that in context. Okay? A matched pair is still a sample mean, but it's for differences. Right? We have a set of data that's been collected. We have 2 entries per thing, per person, per site, per dog, whatever, and we find the difference. And our null is that the mean difference, the average difference, should be 0, meaning there was no effect of what we were testing. And then we define the parameter. Mu is the population difference. And we should say, our direction of subtraction, like before minus after minus before, site 1 with fertilizer versus site 1 without, or something like that. So I'm just going to tell the direction of your subtraction here, okay? So again, I know, you'd write down your alternatives would be mu is less than, greater than, not equal to 0. I'm just writing down the nulls. All right, one proportion z-test. So now our null will be in terms of a proportion, so it will be p equals a number. The alternative would be that p is greater than, less than. So p is the population proportion. And then, of course, you'd add the context. Now, I just want to point out here that each of these things has one list in your calculator, one number, one sample size, and therefore has one parameter and then a number. Once you get down to 2 samples, your null will have 2 parameters. Okay, so like a t-test, you're given a sample mean, so you say, well, I have 1 sample, it's 1 parameter. So once we get down to 2 sample, this is where we write our null in terms of 2 things. So 2 sample t, this is 2 mean, so we write mu. I'm going to put a little blank there. Put a different little blank there. We don't need to define our parameters. We use the subscript for that. We say the mean golden retriever is equal to the mean schnauzer, something like that. The mean man equal to the mean woman. The mean boy equal to the mean girl, whatever. So we don't need to define our parameters for that. All right, so for the null for proportions, same type of thing. Like that, okay? And again, you don't see any p-hats, you just use proportion. Again, the number of things in your sample, I always count the n's. Count the number of sample sizes dictates how many parameters you're using. 1 sample, 1 parameter with a number. 2 samples, 2 parameters, okay? Now, the chi-square goodness of fit test. This is the null where we say, well, the observed distribution of whatever we're talking about, the number of ice cream cones, number of people that walk to work, or that, whatever. The observed distribution is equal to the expected distribution. An easy one here would be like AP scores. That they're designed to have 20% to get a 1, 2, 3, 4, or 5. So you'd say, well, the observed distribution of scores is equal to the expected distribution of scores, something like that. Put it into context. There's no need to then define your parameter as long as you use the context correctly here. Your alternative would be not equal to. It will be every time. The chi-square test for independence. The null is that there is no association between the two categories of variables they're talking about, or that the categories are independent of one another. Okay, and the alternative would be that they do have association, or that they aren't independent. Okay, again, really no reason to define parameters here as long as you use the context in your null and alternative. You know, you say, well, there is no association between the type of car and gender, something like that. Regression. The null for regression, if you remember, is we use this beta, and this is our kind of Greek letter for slope. We usually begin with just, no, there is no slope. There's no linear relationship. And if there's no linear relationship, the slope would be 0. And the alternative would be greater than, less than, not equal to. And again, because we have one sample that made one line, we do have to define our random variable. Beta is the population slope between, you know, blank and blank. It's right between. Okay? Now, I want to fill out one more of these tables for conditions. But again, let me just remind you, count your samples, right? That tells me how many parameters I'm going to write. Be careful with what we're talking about. If it's a sample mean, that's a t-test. If it's a sample proportion, that's a 1 proportion or 2 proportion test. If there are more categories than 2, we've gone into the chi-square category. Regression is maybe the easiest to spot because obviously it's the only one that has to do with a line. And we know if it's asking us to test the slope, we know it's a regression. Okay, so count the samples, and the most mixed up are match pair and 2 sample t. 2 sample, remember, is when we have 2 independent samples from one another. Okay, men and women. A match pair says, well, we did men before and after, or we did this site with and without fertilizer. Where the samples are not independent from one another, they actually have to be linked together. So now we're going to talk about the plan portion of this. And the do and conclude, I would urge you to go back and watch my previous video on hypothesis tests to get, because the do and conclude is typically faster. Okay? The plan part of this is those conditions. And the first thing you should do in your condition part is you should write down what tests you're going to use. Okay? Just write this test down. And then let's just briefly talk about those conditions. Okay, a simple random sample, we want all of our data to be well collected. I'm not drawing it all the way down to regression because this has that special one we usually write liner, and the R stands for random. Okay, so it is actually part of this, but this has its own little acronym. So that's what we want for everything. Okay, if we have 2 samples, we want them to be independent of one another. So I'm going to write independent, independent. Okay? Now, all of these require this condition that the sample size is less than or equal to 1/10 the population size. That goes to every one of these, again, down until the regression equation. Now, beyond that, the t-test requires that magic number of 30, right, that our sample size is, or in the case of the 2 samples, that both of them are larger than 30. And remember, if they're not, we've got to do some kind of graphical check. We need to know something about the parent population, something like that. Where the proportion tests have this NP and N times 1 minus P. And same thing here, except you would check with both conditions. Or both proportions, excuse me. Chi-square goodness of fit and independence. Remember, want our expected counts to be greater than or equal to 5. You should display those. Don't just say, yes, they are. Say the expected counts are this. They're all bigger than 5. Okay, so those are the conditions for these tests. Let me just remind you of regression. This stands for the data was linear, independently collected, The residuals are normal. The variability remains equal. The points don't get further away from the line the further you go out. And we use randomness to collect the data. So again, the do portion of this comes from your calculator. Remember that the t-tests and goodness of fit, and the chi-square tests and regression all require degrees of freedom. Proportions do not. They are, I guess, the only ones that don't need degrees of freedom. The others do. Remember, your conclusion consists of three things. What are you doing with the null? Reject or fail to reject. That's number one. Why did you do it in terms of the p-value? I did it because the p-value was less than 0.05. And then in context, what does that mean? Okay? Again, you could go back and watch a previous video that I kind of went through that very quickly. But this, again, I just wanted to spend a little time reminding you of the way we write our null and alternative and the way we do our plan step, because it really is important to get that right on the AP exam.